Pythonic way to reduce the number of small subclasses in a base class. I find myself writing many small subclasses for predefined objects. However, each subclass I create contains a lot of duplicate code for the base class instantiation. Essentially, I am using subclasses to store default initialization attributes specific to the subclass and common to the base class. Is using many small subclasses with only an init an acceptable use of subclasses? For example, I create a module that contains the base class and subclasses. I have 30 subclasses with slightly different arguments and default arguments. And create instances in other modules through the general animal class, or the more specific, predefined animal subclasses. Tab completion is essential so I can reference specific animal subclasses. I find using a base class with many predefined subclasses creates more explicit code and allows future expansion. Still, this creates a lot of duplicate code and I currently have no unique methods for subclasses. It feels like an incorrect use of classing. I have tried using variables to replace subclass definitions. This is troublesome if I want to modify anything, because I have to remember the defaults and their order, and seems less explicit than subclassing. Dictionaries are nearly as troublesome, because there is as much duplicate code in their definition as the equivalent subclass, and it appears less explicit than the more robust subclass counterpart. Should I reconsider using subclasses in this context? If so, what is the Pythonic way to accomplish this? Should I consider at class method or at static method? I understand what they do in theory, but don't know how / when to implement them. Additional questions? Thank you all for your answers. I have read them multiple times before responding, and have posed slightly modified examples to clarify concepts that still elude me. I am new to Stack Overflow, and responded in this way so that I could elaborate more. If this is an improper use of edit, let me know how to proceed. I take it that you feel subclassing is acceptable in this context? I liked your class variable technique. I plan to implement that. I think your use of quarks holds promise, but without referencing the source animals.py, how do you know what key value pairs are valid in the parent class as I initialize the subclass? They aren't available in context when instantiating the subclass. I considered defining a default set of quarks for each subclass, similar to your class variable technique. However, I don't entirely understand what happens if I override a key value, and then input quarks, where the same key is defined in quarks. Is this valid syntax? Will the cute equals true in dog.quarks override me setting cute equals false in instantiation? Interesting perspective about taxonomy. Fortunately, I do have a finite number of subclasses. I don't need to keep specializing, and for my use, it is acceptable that creating a dog through the animal base class is not type dog. With this in mind, any other concepts to consider?
I would use super and corgs and add any specific attribute that relates only to that subclass.
There's nothing egregiously wrong with the way you're specializing your animal-based class, but you are using a taxonomic system, Python classes and inheritance, designed for a small amount of pragmatic categorization, related to implementing code behaviors, and stretching it into an ontologic classification system/taxonomy. That means there's going to be some rough points, and some occasional idiosyncrasies, counterintuitive results, breakage. For example, if you can instantiate Fido as animal rather than dog, then you won't be able to use this structure to reason about Fido. Eisenson is Fido, dog, would answer false, even though Fido is a dog. Python just doesn't have a rich enough taxonomic structure to closely represent the variations found in nature. Most languages don't, though some like Clo or Prolog might start to approach it. This is not the first time such a problem has arisen. This recent question on programmers.stackexchange.com is just one of many related class hierarchy challenges discussed on Stack Overflow's More Theory of Programming sister site. The second issue here is about simple, concise value setting, not the relative weakness of Python class taxonomies. Your question and some of the answers go through various options, having custom _in and _ methods in each subclass, using a pure corg style of setting, class-based quasi-enumerateds, etc. They all have virtues and drawbacks. When I have faced similar problems, a delegation-based model has proven helpful. Rather than recapitulate it here, this is the relevant Stack Overflow answer, and here is the configuration package that implements it. Options.
What about this? It doesn't create subclasses to define all of your animals, but it does provide a way to define them with far less code than subclassing. Since you are creating instances of your subclasses in other modules anyway, in which you specify features for instantiation, it might work out doing it this way. I am using corgs. You have just the animal base class, and you simply create instances of it, named appropriately, and filled with defining attributes, which it appears you do in those other modules in any case. Create a dog. Or a cat.